In this video, I'm going to discuss polarity of covalently bonded molecules. So remember that covalent bonds are when electrons are shared between nonmetals in order to achieve a noble gas configuration or become stable. But sometimes in this process, the electrons are not equally shared between the atoms in the compound. If there is an equal sharing, we say that the compound is nonpolar. If there is an unequal sharing, we say that it is polar. So what does polar mean? Polar means that essentially because there is an uneven sharing of electrons between one atom or the other, that one end is going to have a slightly positive end and one end is going to be slightly negative. And we call this dipoles, or there's two poles. There is either a positive or a negative pole. And we use this Greek letter delta here with a positive, or the Greek letter delta with a negative in order to show, on the molecule which side is the positive or negative side. So an example of a polar molecule is hydrochloric acid. So let's go ahead and I'm going to show you under the outline. I'm just going to kind of draw a picture of it. And then you can get a sense, and then we're going to look at a simulation. So hydrogen, remember, has one valence electron, and chlorine has 7. So 1, 2, 3, 4, 5, 6, and then 7. So it is going to share this one electron of hydrogens in order to be full and happy with 8. And hydrogen only has one shell, so he's full and happy with 2. So chlorine, if we look on the periodic table, chlorine is very electronegative. It's up and to the right of the periodic table, and so the electrons tend to move in this direction, and so we end up having a negative side over here and a slightly positive side over here. So that unequal sharing makes a polar molecule. Alright, so I'm going to actually open up a simulation. I'll post this simulation on the Moodle so that you can play around with it if you want. And it has a list of a whole bunch of different molecules that I can look at. So let's look at water. So water is H2O, so 2 hydrogens and an oxygen. And I can actually make it put the dipoles, all right, so we'll put the partial charges. And so that shows us, see, we have the delta and we have a positive number here, and you have the delta and a negative number here. So this end ends up being a negative side and this ends up being a positive side, so it's polar. And we can actually put in another little animation on top of it, it's the electrostatic potential, that shows us where the molecule is positive and where it is negative. So water has this red side over here, which is negative, and then this blue side over here where we have the partial positive. Let's grab another one. Let's do CF4. So in this instance, okay, so we have carbon and 4 fluorines. Okay, you can see that there is a little bit of a negative charge here. Let me remove this so you can see that a little bit better. None. So here's negative, here's negative, here's negative, and here's negative. So there's an even distribution of negative charge around the outside. In this case, we have an equal sharing of those electrons, and therefore this is nonpolar. And if I pull it up and I look at the electrostatic potential, you can see that it's all sort of this whitish gray color, and so it's even all the way around the outside. There is no negative or positive end. So this would be an example of a non-polar. So you can use a simulation and play around with it to sort of get the idea of polarity if you want to know the polarity of some specific molecules if you're working on a classwork or something like that.